Alright, in this video we're going to take a look at addition and subtraction of rational expressions. Well, before we begin, we better figure out what rational expressions are. All a rational expression is just it's a fancy word for a fraction, but they can also contain variables. So you're all used to fractions. For example, let's take a look at the problem 2/5 plus 1/5. Well, as we learned way back in primary school, the sum of those two fractions, you simply add the numerators together as long as the denominators are the same. Answer 3/5. Likewise, if we had an expression, a pair of expressions that were containing variables, for example 1 over x plus 2 over x, it's the same logic. And that is, if the denominator is the same, we just keep that denominator of x. Don't be tempted to add the two x's together and add the numerators. The answer is 3 over x. So let's go a little more complicated now. Let's say we had 3 over x cubed plus 5 over x. Well, just like regular fractions, you cannot add them together unless they have the same denominator. So what you have to find first is the common denominator. And the common denominator in this case will be the highest power of the x when you compare the two denominators. So our LCD, or our least common denominator, in this scenario is x cubed. So we have to make the second fraction have a denominator of x cubed. So in order to do that, what we will do is multiply the denominator by x squared. So you know that whatever you do to the denominator, you must do to the numerator also. And that way we're not changing the value of the fraction because we're multiplying it by x squared over x squared, which is equivalent to 1. So now the problem is 3 over x cubed plus 5x squared over x cubed. The denominators being the same, we just simply add the numerators together and keep the same denominator. X cubed is the denominator, and when I add those two terms in the numerators, I'm going to put them in the correct order. So let me go 5x squared plus 3. And that is the final answer. Alright, let's bump it up a notch to a different type of problem. Let me scroll up a little bit. Problem number 4. 4 over the denominator of x plus 2 plus 3 over the denominator of x squared minus 4. Alright, again, you cannot add these two fractions together unless the denominators are the same. So before we determine what the common denominator is, what we'll do is factor any denominator that needs it. And the second one, obviously, is the difference of two squares. So we factor it into x plus 2, x minus 2. Alright, again, the LCD will be the combination of all different factors that you see in the denominators. So you see x plus 2, and you also see an x minus 2 in the second one. Alright, the x plus 2 is shared, so we're not going to count it twice because the highest power of any x plus 2 expression is to the first power. And the x minus 2, there's only one of those also. So the least common denominator is x plus 2, x minus 2. So what we'll do, we'll come back over to the problem and we'll give that first fraction the factor that it does not have. So we're going to append an x minus 2 to the denominator and also the numerator. Okay, the second fraction is going to remain unchanged. X plus 2, x minus 2 was already there in the denominator. So now let's add the numerators together and put them over that common denominator. And I'm going to go ahead and FOIL the denominator back, and we know that it equals x squared minus 4. The numerator I need to distribute, so in the first fraction, 4 times the quantity x minus 2 is 4x minus 8. And then we're going to combine the second numerator plus 3. And now we add terms in the numerator together that we can combine. Then negative 8 plus 3 is negative 5. So the final answer is 4x minus 5 over x squared minus 4. So going through a bunch of little steps there, but the process really is not that difficult. So scrolling up, let's take a look at one more example. Well, let's switch over to subtraction and see if there's any difference. Well, there is no major difference other than the fact that you have to subtract the second numerator. So the first thing you always do when you're adding or subtracting rational expressions is find the least common denominator. Again, looking for every different factor you see the first denominator, x minus 1, counts as its factor, and the second denominator, x minus 2. So the LCD is the combination of both of those. So we'll go and give each fraction what it does not have. The first fraction needs an x minus 2 in order to have the common denominator. So I put an x minus 2 in the denominator and also in the numerator. The second fraction needs the x minus 1, so I put it top and bottom. And there we go. Now at this point, what I'm going to do is multiply those two terms, those two factors in each denominator together, and get the common denominator of x squared minus 3x plus 2. The denominator is done. Now, distributing in the numerator, 3x minus 2 becomes 3x minus 6. Now here's where you got to be careful. A common mistake is to make a sign error in this situation. If you treat that sign, that negative, as a negative 1 instead of a subtraction, or you can just count the negative taking it with the 4, so distribute negative 4 times x is minus 4x, and then again negative 4 times negative 1 is positive 4. So a very common mistake is to have the wrong sign there, so watch out for that. At this point, all we have to do is combine the terms in the numerator. We have a 3x minus 4x, which is negative 1x. So I'll just write negative x. And then minus 6 plus 4 is minus 2. And that's all over our common denominator, x squared minus 3x plus 2. Okay, let's do one more subtraction problem, since we only had one of those so far. And we'll do, how about 2x minus 1 over x plus 3, subtract 9 over x squared plus 3x. Alright, process that we've learned so far is, first, if denominators need factored, factor them. Well, the second denominator, we can factor out a greatest common factor of x, so it's x times quantity x plus 3. Alright, all denominators have been factored, so now we want to determine the LCD. Every different factor we see, well, we see x as a factor, and we see x plus 3. So that is the common denominator. So I need to give each fraction what it does not have in order to have the common denominator. The first fraction, 2x minus 1, has the x plus 3 in the denominator, but we have to give it an extra x. So I'm just going to stick an x down there and go x plus 3. If I gave it to the denominator, got to give it to the numerator. So I'll just stick it up there and put parentheses. Second fraction is set. It doesn't change at all. So let me leave it just as is. Alright, at this point I'm going to do my denominator and just put it back together. That's x squared plus 3x. In the numerator, distributing my x on the first fraction, x times 2x is 2x squared. X times negative 1, negative x. And the second fraction, minus 9. And that appears to be done. That's all there is to it. So addition and subtraction of rational expressions is not too difficult as long as you remember the process. Factor denominators if necessary, and then find the common denominator by putting together all the different factors contained in the two different denominators together, and going from there by combining the terms in the numerator and then combining like terms. Alright, that'll be the end of this, and our next video we'll take a look at, let's do some rational equations now that we know how to operate with rational fractions. Over and out.